Hello everyone and welcome to the fourth part of the previous year question paper of Applied Mathematics held at SIES Graduate School of Technology. We are on to question number 2D carrying the weightage of 10 marks, and this question is based on partial derivatives, its application. We are required to find the extreme values of the given two variable function. Let us first declare this function as f of xy. Now we will be needing to find out the first order and second order partial derivatives. So let's talk about del f with respect to del x. That's going to be 3x squared plus 3y squared minus 30x plus 72. We'll need del f over del y. That's going to be 6xy minus 30y. Then also we'll be needing the second order partial derivative, del square f over del x square, del square f over del y square, and del square f over del x del y. So the first one is going to be the partial differentiation of 1 with respect to x, and that's going to be 6x minus 30. The second one is going to be partial differentiation of equation number 2 with respect to y, and that turns out to be 6x minus 30, while the third one is going to be the partial differentiation of equation number 2 again with respect to x. So that turns out to be 6y. Now we are going to call the second order partial derivatives as R, S and T. Now we got to find out the stationary points for the given function. So for that we are going to use equation number 1 and 2 and set them to zeros. So let's check the stationary points. So for that we are going to say if del f by del x is equal to 0, this gives us that 3x squared plus 3y squared minus 30x plus 72 is equal to 0, and we can factor out 3, so we will be getting x squared plus y squared minus 10x plus 24 is equal to 0. Let us call this as equation number 3. And likewise we will also let del f over del y is equal to 0, and this gives us 6 into xy minus 30y is equal to 0. Factoring out by 6, we will be getting x into y minus 5y is equal to 0. And as you can see, we can factor out y, so we will be getting y into x minus y is equal to 0. This gives us that y is 0 and x is equal to 5. Now we are going to use these latest two values, y equals 0 and x equal to 5 in equation number 3 to get the stationary points. So when you plug in y equal to 0 in equation number 3, we get x square minus 10x plus 24 is equal to 0. And that is nothing but factorizes to x minus 4 into x minus 6 equals 0. So we get here that x is 4 or x is 6. So we can say that a is 4 comma 0, b is 6 comma 0. These two are the stationary points when we solve for y equals to 0. And likewise, plugging in the value of x equals to 5 in equation number 3, we are going to get 25 plus y squared minus 50 plus 24 is equal to 0, and this reduces to y squared minus 1 is equal to 0, which gives us that y is equal to plus minus 1. So therefore the another pair of stationary points are C, which is 5 comma 1, and D, which is 5 comma negative 1. And now we are going to use these 4 points, substitute these values in the second order partial derivatives over here, and decide whether these points form a saddle point or points of maxima or minima. Let us check with A. So the value of R, that is the second order partial derivative of f with respect to x, is going to be 6 into 4 minus 30, which turns out to be negative 6. The value of t for the same number is again going to be -6, wherein the value of s is going to be 0. And next we are going to evaluate the value rt minus s squared, and that is going to be -6 into -6 minus 0 square, which turns out to be 36, which is a positive number. And same way based on b. Now since rt minus s square is positive, we can have a conclusion that point A is going to be a point either of maxima or of minima. And to decide that, we need to look at the value of r. And since the value of r is negative, we can conclude that point A is a point of local. We can conclude that point A is a point of local maxima. Now let's move on to point B. Now point B is 6, 0. Again, we got to evaluate r, t, and s at this point. So this is going to be 6, that is 36 minus 30. This is again going to be 6 followed by a 0. And here we get that rt minus s square is going to be 36 again, which is a positive number. And since it's positive, we can go ahead further and check the value of r. And here you can see that r is a positive number. So based on this, we can have a conclusion that point B, that is 6, 0, is a point of local minimum. Moving on to the point C. So we'll be having 6 into 5, that's 30, minus 30, which is 0. And then again here we will get the same number, 6 into 5 minus 30, which is 0. We need 6y, that's going to be 6 into 1, which is 6. Now rt minus s square is going to be 0 into 0 minus 6 square, which is negative 36. And in this case it is negative, so we will say that point C is a saddle point. For point D, we will be again having 0, 0 and negative 6, and we go for the value of rt minus s square. It again turns out to be negative 36, which is a negative number, and so again point D is going to be a saddle point. Now for the last part, since we have got 2 points for local extrema, we need to also find out the local extremum values. So in that case, we will be finding out what is f of A, that is f of O, 0, and f of B, which is f of 6, 0. So on substituting these values in the function, you are going to get that f of A is going to be 112 and f of 6, 0 is going to be 108, and this is the local maximum value of the function, while 108 is the local minimum value of the function. Now let us quickly summarize the steps involved in solving such type of problems. The first step that you will be required to do is find out the first order partial derivatives fx, fy, and the second order partial derivatives fxx, fyx, and fyy. Then step number 2 is to find out the stationary points. For this, you are going to solve simultaneously fx equals to 0 and fy equal to 0. This will give you ordered pairs, and those ordered pairs are going to be the stationary points. Step number 3. So suppose say you get these points as capital X, capital Y. Step number 3 is you are going to evaluate R, S, and T. R is fxx, S is fyx, and T is fyy. So we'll be evaluating these at the stationary points. And step number 4 is to perform a little arithmetic here. So we need rt minus s square. And step number 5, we'll come on to the conclusion. So if rt minus s square is negative, then point x is a saddle point. If rt minus s square is positive, then we need to look at the value of r. So if r also happens to be positive, then we will say that x is a point of local maxima, is a point of local minima, and if it happens that r is negative, then x is going to be a point of local maximum. There are more possibilities. There are more possibilities which are not listed over here, so we'll not get into those. Now let's move on to next question, that is question number 2E. Now question number 2E is based on Gauss-Seidel iteration method to solve the given system of equations. We will be needing a calculator, so I'll be equipping myself with a scientific calculator. The steps that I'm going to perform on the calculator might vary depending on the version of calculator which you are going to use. So let us label these equations as 1, 2 and 3. Now from equation number 1 we can say that x is equal to 3 minus 2y minus z. From equation number 2 we get y is equal to, this is an equal to sign, so we'll be getting 18 minus 3x plus z over 20, and for z we will be having 25 minus 2x plus 3y over 20. Let's call these equations as 4, 5 and 6. Now since we are going to use the scientific calculator, please make a note that on the scientific calculator we are going to take help of the buttons A, P and C, which can be accessed using alpha. So we will be plugging in A instead of x, B instead of y and z instead of c. So let us have a table over here. So here we'll have the iteration number, then here we'll have xn, which is going to be represented by A, we'll have yn represented by B and zn represented by B. Now for the 0th iteration or the initialization, we are going to plug in all the values as 0. Okay, so on calc, let us store 0 in A, let us store 0 in B and 0 in C. So you see that 0 is plugged into all three A, B and C variable. Now have a look at equation number 4. From equation number 4 can be rewritten as 3 minus 2 times B minus C. Equation number 5 can be rewritten as 18 minus 3A plus C over 20. And equation number 6 can be rewritten as 25 minus 2a plus 3b over 20. This we are doing just for the consistency, that we do not get messed up with x, y, z and a, b and c. Since on calculators we will not be able to use x, y and z, we will be using a, b and c. Now for the first iteration, we are going to plug in the available values, the most recent available values in equation number 4, which is this version. So let us type in equation number 4 on the calc. So it is given by 3 minus 2b and minus c. So you see that this value is turning as 3. So that's the first iteration. So we are going to now store this value in A. So let me have shift, store and A. The older value of A was 0 and now it has been modified and the new value of A is 3. Now when we move on to calculate yn, we are going to use the latest available values of x and z. So you can see that the latest available value of x is 3 and that of z is 0. So let us move on to equation number 5, which is this. We'll enter this in the calculator. So that is as fraction. So we have got 18 minus 3a plus c divided by 20. So you see that this is 0.4500 and we got to store this now in B. So we'll be having shift, store B. And now for the value of z, we are going to type in this equation in the calculator. So we have fraction. In the numerator we got 25 minus 2a plus 3b, and in the denominator we have got 20, and this equals to 1.0175. We got to store this now in C. Once you do this, all the subsequent steps are very quick. So what you got to do is, using the navigation button on the calculator, you got to look out for the equation that gives us the value of x. So this is the equation that gives us the value of x. So we're just going to press equal to, and you get the new value of x. So in this case, x2 is 1.0825. You store this in A, and then look out for the equation that gives the value of y. This is the equation that gives the value of y. Press equal to, you get the new iterated value, so that's 0.7885. Store this in B. Then look out for the equation that gives us the value of z. This is the equation that gives us the value of z. Press equal to, you get that z2 is equal to 1.2600. Likewise, we'll move on to the third iteration. So we need to store this in C. Now we look out for the equation that gives us x. So this is the one. Press equal to, you get it to be 0.1630. Store in A. Look out for the equation that gives y equal to, you get 0.9386. Store this value in B. Look out for the equation that gives z, which is this. Press equal to, you get 1.3745. Store this in C. So that's the third iteration. For the fourth iteration, look out for the equation that gives x. Press equal to, so you get the next value to be negative 0.2517. Store this in A. Look out for the equation that gives you y. So this is the equation that gives us y, and for this we get it to be 1.0065. Store this in B. Look out for the equation that gives you z. This is the equation equal to, you get it to be 1.4261. So we'll be storing this value in C. Now looking for the equation that gives us x, it is this, and we get it to be negative 0.4391. Store this in A. Equation giving us y equal to is 1.0372. Store this in B. Equation giving us z is this, equal to, we get 1.4495. Store this in C. So let us stop over here, and you can also observe that these values are getting closer. You can look at the values of z and y, they are getting closer in the sense they are converging. However, the same is not reflected in x. We don't have yet a conclusion that what is the solution for this using Gauss-Seidel, but due to the limitation of time, we are going to stop over here. In most of the cases, the number of iterations is usually provided. So that's all about question number 2E. Now let us move on to question 2F. Question 2F is based on system of equations. We are going to solve this using matrices. It says that find the values of k for which the system of equations. We are given a 3x3 system, and you can see that there are unknown k's involved over here. Have a solution and then solve them completely for these values of k. So to begin with, we are first going to rewrite the given system in matrix form. So rewriting in matrix form. Let us use the augmented notation. So we have A augmented B is equal to 1, 2, 1, 3, 1, 1, 1, k, and 3, 1, 3, k square. Now we'll perform elementary row operations and try and reduce this matrix to its row echelon form. So we'll be starting with these two elements which belong to R2 and R3. So on R2 we'll perform R2 minus R1, while on R3 we're going to perform R3 minus 3 times of R1. So A augmented B transforms to, the first row remains unaffected. So here we get 0, then negative 1, 0, k minus 3, while the third row becomes 0, negative 5, 0, and k squared minus 9. Now we'll move on to the third row element, -5, and reduce it to 0. So we'll be performing on R3 minus 5 times of R2 since the pivot element is in R2. So we will be getting that A augmented B is transformed to the first and second rows now remain unaffected. So here we'll have 0 and then this is going to become 0, 0. And over here we'll get k squared minus 9 minus 5k plus 15. So this is going to be 1, 2, 1, 3, 0, -1, 0, k minus 3. And the third row will have 0, 0, 0, k squared minus 5k plus 6. Now you can see that we have reached a row echelon form. So we have got the pivot elements to be 1, -1, and depending on the value of k, this could also be a pivot element. So for the next part, we'll be having a check on the question. So the question says that the given system of equation have a solution. So we have to assume that this system is solvable. That means it is consistent. And based on that assumption, we can say that the ranks of A and A augmented B must be same. So here you can see that rank of A is equal to 2 since A has only 2 pivot elements. And we'll now say that since system is consistent, this gives us that rank of A and rank of A augmented B must be same. In this case, it must be 2. So therefore, the third element, which is k square minus 6k, k square minus 5k plus 6 must be 0. So therefore, k square minus 5k plus 6 must be 0. And this gives us two linear factor, k minus 3, k minus 2 is equal to 0, and therefore we get that k is either 2 or 3. So we have two possible values of k. One is k equals to 2 and one is k equal to 3. Now once you plug in k equal to 2 in the last augmented matrix, you get the augmented matrix to be 1, 2, 1, 3, 0, -1, 0, -1, 0, 0, 0, 0. And over here we will be getting 1, 2, 1, 3 and 0, -1, 0, 0, 0, 0, 0, 0. So this is A augmented B in either of the cases. Now let us reconstruct the system of equations from this. So from k equal to 2, we get the system to be x plus 2y plus z equals to 3. And -y is equal to -1, which gives us y is equal to 1. Now since the rank is 2 and the number of unknowns is 3 in this case, so we have got one free variable. So let's say that z equals to t is the free variable. So substituting the value of y and z in equation number 1, we are going to get x is equal to 3 minus 2 minus t, which is equal to 1 minus t. So therefore we get that the solution set is going to be 1 minus t, 1 t, where t is a real number. So this is the solution when k equals to 2. Now moving on to k equals to 3. Again reconstructing the system of equation, we will be getting x plus 2y plus z is equal to 3. From the second equation, we get minus y is equal to 0, which gives us y as 0. Again over here, we will be needing one free variable. So let me take z is equal to t, where t is a real number. So substituting z equal to t and y equal to 0 in equation number 2, we will be getting that x is equal to 3 minus t. So therefore the solution set in this case is 3 minus t, 0, t, where t is a real number. So We have solved the given system of equation completely for the two values of k that we have obtained. With this, we'll be stopping in this video. Thank you so much for watching till the end. If you have not yet subscribed to my channel, then do subscribe and press the bell icon for receiving notifications about the upcoming videos that I am going to upload in this series. Thank you so much once again and happy learning.